Today we will learn more about data types in Java. We already know the integer type or int. Altogether, Java has 8 primitive data types. They can be broken down into 4 categories. The first category embraces integer numbers. They are byte, short, int, and long. All of them represent integer numbers. The second category includes floating point numbers, that is, fractional numbers. They are float and double. The third category are the characters. The only data type belongs to this category, it's char. It's used to work with characters, both letters and numbers. The fourth category is logical. Only one data type belongs to this category, Boolean. It can store one of 2 possible values, true or false. Let's take a look at integer numbers. It has been mentioned that it consists of byte, short, int, and long. All these types differ by the number of values they can hold and hence the amount of memory they utilize. And the byte type, as it follows from its name, takes up 1 byte and can hold numbers between -128 and 127. This data type is convenient when the data comes from the internet or from files. When we need to get those data, we read them byte-wise and store the values in a byte variable. The second type is short. It requires 2 bytes and can hold values from -32,000 to 32,000. This data type is used once in a blue moon. Throughout my career, I have never seen anybody use this data type. For work with integer numbers and in calculations, int type is most commonly used. You already know this data type. It requires 4 bytes and can hold the values from approximately -2 billion to 2 billion. This is the most common integer data type. The last type is long. It is used when the values to be stored are so huge that they cannot fit the int type restrictions. The data type requires 8 bytes and can store values like this one. These data types can be worked with similarly to the int type. In order to create a variable of a required type, specify the type and the name of the variable. It can be initialized immediately or later. Byte number equals 120. Or short number equals 3,500. Int number equals 950,000. Long number equals a very big number. I believe the theory is enough. So let's get to the code and solve a small problem. Given is the speed of light, which approximately equals 300,000 kilometers per second, and a number of days. We need to write a program which counts and displays the amount of kilometers traveled by the light in those days. While I'm launching the IDE and creating a new project, decide which variable is best for storing the result. Create a new project and call it variable. Add a new class, call it var. It's short for variable. Create a program entry point and add our variables. The first one will store the number of days. The int type is good for it. Let there be 1,000 days. Int days equals 1,000 semicolon. The second variable will be for storing the speed of light, which is constant. So again, int type will do for it. Call it speed. Int speed equals 300,000 semicolon. As the speed of light is 300,000 kilometers per second, we will need to convert days into seconds. The number will be quite big. Let's use long type for it. Type long seconds equals. We need to multiply the number of days by the number of hours in a day, that is 24. Then by the number of minutes in an hour, 60. And by the number of seconds in a minute, 60. Now we are ready to calculate the distance. In order to find out the distance, the speed must be multiplied by the time. The resulting value will be very big, so we will use long type. Long distance equals speed multiplied by seconds, semicolon. Let's display the result. Now run the program. As you can see, we got a very big value which exceeds 2 billion and would not fit into int type. Let's try to alter the type of the variable to int. We get an error warning here. To find out what the error is, hover your mouse over the underlined text and see incompatible types, required int, detected long. But how did the program understand that this operation results in long? It neither calculated the value nor tried to guess which type is more suitable. Let's see what numbers were used in the expression. Variable speed is of int type. Variable seconds is of long type. In expressions, the total result is converted to the biggest type used in the expression. In this case, variables of int and long data types were used, so the expression is converted to the biggest of them, long. It means that to correct the mistake, we need to change the data type of variable seconds to int. In this case, the number of seconds will be approximately 86 million. Since int type is restricted to 2 billion, it is applicable to the variable. We will store this value without issue. Now there are no errors, so let's run the code and see what we have. Well, there is a result on the console, but it's definitely incorrect, to say the least, because we got a negative number. Let's see why it is so using the example of a byte variable. Let's create a variable. Byte A equals. Byte type can store values between -128 and 127. Let's assign it a value of 127 and then increase it by 1. If you remember, the shorter way of adding 1 looks like that. So let's print its value on the console. Let's delete this expression and run the code. The output is -128. Since the byte variable cannot store numbers that exceed 127, it will be assigned the minimum possible value, -128. If we add 2, the result will be -127. And so on. Adding more will increase the value until it reaches 127. And then the count will start over from -128. The same happened in our case. Eventually, the value of variable distance got so big that the number did not fit into int type, so the value exceeded 2 billion something, and the program started counting from the beginning, approximately -2 billion. Then it reaches 2 billion something again, and so on. And eventually we got a negative number. There is another thing to be considered. What if we change the data type of variable distance to long? Let's delete the example with byte variable and print the value of distance on the console. Run the code and we still get a negative number. Can you guess why this happened? As you already know, in expressions, the total result is converted to the biggest type used in the expression. In this case, variable speed is using int type, and variable seconds is also using int type. Thus, the value of the whole expression will be converted to int type, which cannot store such a big value. So the result is a negative number. But why is there a mistake? Why a long type variable can be assigned an int type value? It's called automatic type conversion. Since int type requires less space than long type, program will convert the result into long type automatically. The same will take place if we cast byte into int. Let's try this. Let's create a byte type variable a and assign it a value of 10. Create an int type variable b and assign it the value of variable a. As you can see, no errors occur in this case. We can print the value of variable b and get the result 10. Byte type requires less space than int type, and thus there are no errors. Byte type is seamlessly converted into int type. And here's the last thing I would like to talk about today. Let's delete all this code and create an int type variable. Call it a and assign it the value of 15. This value is small enough and will fit a byte type variable. Let's create a byte type variable. Call it b and assign it the value of variable a. As you can see, regardless of the fact that this value fits the byte type variable, we encounter an error. And this error emerges because there is no automatic type conversion into a smaller data type in Java. But if we still need to assign the byte type to our variable, we can cast the type, that is, do it manually. Then we bear responsibility for whether the value of an int type variable fits a byte type variable. This is how it's done. Put round brackets before the name of the variable and specify the data type we want it to be. In this case, we want to cast the byte type. Specify byte. As you can see, the error warning has disappeared. And when we print the value of variable b on the console, we can see that there are no issues. The result is 15. At this point, this introduction to integer types is over. Practice creating and converting the types automatically and casting them manually. If something seems unclear on this topic, look for additional information online or send me a message. Understanding data types is crucial because you will need this knowledge very often. See you in the next lesson.